Well, hopefully you caught my rather egregious error over here, because maybe you've actually memorized these formulas. I derive them usually in my head using Euler's formula, e to the I theta equals cosine theta plus I sine theta. You just apply that to e to the alpha plus beta, and then you apply it to e to the I alpha, e to the I beta, multiply those together and so forth. And I do that in my head, and I just accidentally wrote down what you get for the cosine, the real part of the product rather than the imaginary part. That's what I did, but don't do that yourself. Okay, I mean, by all means know how to derive these once you see it, if you haven't already. But it should have been sine of alpha plus beta is cosine alpha sine beta plus sine alpha cosine beta. And I could have checked that out using a couple of simple angles, but it's getting kind of late in the day and I'm starting to get a little hungry, so, no excuse, but I screwed it up. Now, this is the way it actually comes out, and you should verify that. Okay, and then I've written it out correctly over here. And now we want to go on and see what happens if we take the limits. Okay? So what we want to do is now, we want to find the limits. I'm getting a little tired of that green. Let's choose something else. I haven't used a lot of orange. Find the limits as delta x approaches 0. Now, we have talked about why you'd want to do that, because we want to talk about what this means on a graph, but since we're into the algebra of it, let's go ahead and evaluate the limits, okay? Yeah, I see a mistake over here too, that's plus. Okay, so let's see if you can do it. What's the limit of this as delta x goes to 0? What's the limit of this as delta x goes to 0? And that should be x, not delta x. That would have turned out rather badly. That limit of this, the limit of this. Okay? And the limit of this. But this is a little trickier, because you got to know how the sine and cosine functions behave, and hopefully you do, but I'll kind of fill that in. So, right now, see if you can find those limits, and I'm going to proceed without going to another video to work this one out, and probably this one as well, and then leave it to you to get these two, and then we'll talk about this one. Okay, so you should pause and work out this limit. Okay, well, the limit as delta x goes to 0 of 2x plus delta x equals what? Just intuitively, if delta x approaches 0, then 2x plus delta x is going to approach 2x. Now you can use the rules for limits. That'd be the limit as delta x goes to 0 of 2x plus the limit as delta x goes to 0 of delta x, which equals what? Just 2x plus 0, which equals 2x. Okay? So that's quite straightforward. Hopefully you got that. Whether you just saw it intuitively or whether you went ahead and used the properties of limits, I think you probably would have had very little trouble doing this, especially if you've seen it already. Now, let's see if you can work this one out. I recommend pausing, but I'm now going to go ahead. So if you haven't paused and want to, you'd better do it. Okay, well, intuitively, as delta x approaches 0, x plus delta x is going to approach x, right? So that delta x will just kind of disappear. Now, I'm not going to try to break this down to all the rules for limits and so forth. I'm just going to say that it should be pretty obvious that if you allow delta x to shrink to 0, this denominator is going to shrink to just plain old x times x. I'm being a little bit cavalier, but this is sufficient, this part of the course, although you want to be able to rigorously apply the rules of limits. And this is just 1 over x squared. And there's something wrong with this because it should be negative 1 over x squared. So if I look back to what we did previously, I hope I find that I have a minus in front of that, and I do. So previously we did work out the negative, I just didn't bother writing it down here. So we have a negative, we have a negative, we have a negative, so now we have a negative. And that's what we get for 1 over x. Okay, now for square root of x, well, go back to, well, take the limit of this expression, see what you get. For the 1 over square root of x, take the limit of this expression and see what you get. And you can do that rather easily, you just have to be careful. You can really literally just replace the delta x with a 0 and think about why that's valid. So do that and see what you get, and see if you can get it into the final simplified form that I'm going to attempt to get. Okay, well, I'm pretty sure I'm going to get it, but see what you get. Work it out. We'll come back in the next video.